All right, so today we're going to be talking about planetary boundaries. What is a planetary boundary? So basically, as you see here, we have 9 different categories with the green, yellow, and red areas. So we're going to talk about that real fast. This green area, that's below a boundary. We can kind of predict the patterns and stuff like that. It's not really at risk. As you can see here, ocean acidification is moving up towards that yellow area. And within that yellow area, that's a zone of uncertainty. We're not exactly sure what's going to be happening. It's a little bit hard to predict patterns. And once you kind of reach that red zone, we really have no idea what's going on within that environment. So that's what we're trying to avoid here with other things such as land system change. But let's talk a little bit more in depth about ocean acidification.
Ocean acidification occurs when carbon dioxide is absorbed by ocean water, which greatly reduces the pH levels. Calcium carbonate minerals make up skeletons and shells of several oceanic species. Because of oceanic acidification, many of the minerals that are present within these shells and skeletons are not present, which in turn affects habitual behavior and ability of these animals. Significant future projections predict that oceans will become more and more acidic. Surprisingly, photosynthetic algae and different types of seagrass will benefit from higher CO2 levels. However, since shelled species are being harmed by the rising acidification level, the whole food chain will be affected since shelled organisms not only feed many species of fish, but also clean areas such as coral reef. The rising CO2 affects humans who work in the fishing markets because pertaining to shelled organisms, entire oyster systems are failing, costing fishermen in upwards of $100 million annually.
The Chesapeake Bay Foundation offers citizens to fund and support local ecosystems that have a global difference. Donating money to this organization can go a long way. One way to contribute is directly become a member or even volunteer to fight the ongoing ocean acidification problem. Scientists are currently in the process of adding pH, oxygen, chlorophyll, and respiratory sensors to our existing moored and underway systems to have a more accurate and precise study the changes with ocean acidification using automated analytic systems. On a smaller scale, scientists can use an Oak-Ton waterproof pH 150 meter and an X-Tech CO2 100 CO2 monitor. The University of Alaska has top-of-the-line scientific research regarding to ocean acidification. They measure the pH level of the surface to an average of 8.21 at the beginning of the Industrial Revolution to about 8.10. This research concludes to an estimate of 0.3 decrease in pH level by the year 2100.
Human actions have accelerated ocean acidification, but humans can also slow down the process with effort. There are many things an individual can do in the community or on a global level that can help curb the effects of ocean acidification, such as using and creating more efficient energy so there is less CO2 being released into the atmosphere, and by protecting marine habitats and wildlife so that the ocean can bounce back the damage that has already been caused due to ocean acidification.